Welcome back to another DB Services demo. My name's Katie, and today we're diving into an important part of FileMaker development that often gets overlooked, the testing. Whether you're building a brand new solution or maintaining an existing one, making sure your work is reliable and resilient is critical. FileMaker makes it easy to build fast, but without the right testing mindset, small mistakes can turn into major issues later on. In this demo, I'm going to show you practical ways to test your FileMaker applications as you build them, catch problems easy, and use some of FileMaker's best debugging tools to make your life easier. Let's jump right in. Our first tool that we're going to be using is the Script Debugger, which lets us step through scripts in real time and find where things are going wrong. To access the Script Debugger, you're going to use the Tools tab in FileMaker, and you can see the Script Debugger here. That's how you access it. If you don't have this tools menu up here, it's likely because your file does not have this use advanced tool checkbox checked on. If you don't have that on, you can go ahead and click it and then restart your FileMaker application. That should show the tools up there. I'm on Mac right now, but if you use Windows, you can simply go to Edit and you'll see settings there as well and do the exact same thing. Just restart your FileMaker and all will be well. The other thing in here of note is the data viewer that we're going to also be using during our demo, and also this database design report button. We're going to be using all three of these in our demo to show you kind of a little bit of how we use Debugger and the data viewer at DB Services and how you can use it as well. Since I'm using Mac, I actually have shortcuts on here that you can add to. So natively, the FileMaker application that you're using doesn't come with shortcuts, but I've added some. So if I do Command G, automatically pops up the Script Debugger, super helpful. And now that we have the Script Debugger open, we can go ahead and press our button to run error trapping demo. That's going to pop up with an example script that I'm going to walk us through a little bit. So here we see we've got a couple of options that are grayed out. This is just because we actually haven't ran the script yet. We're going to need to do that. But the rest of these options here, I can walk you through what all of these different things do. This first one here, the pencil icon, is actually super helpful. It will open up the script that you're looking at. So the script that we're looking at right now is error trapping demo. When I start this script, with the step into button, this will go ahead and activate. And if I press this button, it will open the script itself. So not necessarily the script workspace, but more like just the single script, and I can edit it from there. It's super helpful. The next button here is the play button. This one will play, it's called continue, but it'll play all the way through your script or up until a breakpoint. So if you have a breakpoint anywhere, maybe in a subscript or in the actual script you're running, it'll stop right on that breakpoint. This stop button right here will halt the script just where it stands, so it won't finish the script. It'll just halt it. It's good if you need to not run through your script. It's good to have a way to stop it. This next one over here is the step over button. That one is super helpful if you have a subscript of some kind, something like that, where you don't want to step into it. Every time you're running the script or debugging it, you can just step over it. That will step over the entirety of the subscript as long as there's no breakpoints in there. So if there's a breakpoint in there, it'll go ahead and stop on that breakpoint. But if there's no breakpoints, you just want to skip the script, this is super helpful. If you are running this and it's not a subscript, it behaves the same way as this step into button. The step into button is just kind of your next line. So, if you're debugging, line by line, this is a button that you're going to use probably most, just to go next line, all the way down. This next one here is called step out. And that's super helpful if you're in a subscript and you want to go back to the parent script, then you would press this step out button. And as long as there's no breakpoints further on in the subscript, it just jumps you right back to the parent script, no problem. And you can continue debugging the parent script. If you are in the parent script, so you're not in a subscript at all, this button behaves similarly to this continue button, where it just continues through the remainder of the parent script, unless there's breakpoints of any kind. This next one here is the set next step button. And what that one does is if you want to go to a particular line in particular, if you want to skip over a few, if you want to go back and rerun a line or something like that, you can click on a line and then press this button to go to it. And then using the step into button, you can continue the script from wherever you specified, which is super helpful at times if you want to rerun something, if you really want to rerun with a different variable sometimes. Super ideal. These are all great tools that we use. Down here, we'll have the pause on error checkbox. We don't tend to have this one on quite as often, but what this one does is if you have this checked on and then you close the script debugger for whatever reason, and you're running through, it will pop back up if you have an error of some kind. So if you went ahead and closed down your script debugger and then we ran this demo, for example, we would see that the debugger pops right back up with this pause on error, which is super helpful in some cases. In other cases, such as if you're running a loop and you have a go to next record and exit after last, that will also flag as an error, even though it's technically an error that we expect. That would also pause on error, so you don't generally want to keep this on. We don't generally keep it on, but it is handy in some cases. If you have like a really long script, you don't want to sit here and babysit it, waiting for an error to happen. This is super helpful to stop the script wherever it is whenever there is an error. So I'm going to turn this off for now. There are two more options that we can click on here. This one is the disable or enable script triggers. Again, helpful in some cases if you want to remove the script triggers that are happening, if you want to focus on one, you don't want to be interrupted by multiple scripts, this can be helpful. We also have this open data viewer button, which can be helpful at times if you want to see something in particular, super helpful for that, just to have it kind of at your fingertips. Again, really great resource. And we are going to jump right back into debugging our script. So let me pull up the script debugger again. And let's go ahead and press this button to get us started. Alrighty, so I'm going to step into our script. And this is our script made by our standards. We're going to look at some different examples of when you should error trap. These aren't all the examples of when you should error trap, but it's a good baseline for getting started. First off, we're going to allow user abort off and set error capture on. Just make sure that we can grab those errors when they appear. Freeze window, we just generally have that if we're jumping between. We don't really need it in this case, but part of our standards, so we always include that. Next up, we set a variable called task name. And this is super helpful for when we go ahead and make those custom dialogues after each error. There are cases where we don't always make custom dialogues, but for most cases, it's really helpful to have a task name. That way, if a client sends us something like a picture and says, hey, this is what I'm looking at, this is the error that we see, we can see that task name in the title and go ahead and search a database design report or a DDR for that, which we're going to get into a little bit later in this demo. But it's super helpful for debugging when a client is having an issue and we need to look into it. This here is an example subscript. So we've got a subscript, we're using perform script, and this is just a subscript called example for the purposes of this demo, no parameters. And how we error trap this subscript is we're actually going to grab the result. So we can grab the result using get script result, and that will go ahead and parse for an error. So when we exit scripts, we will exit with a JSON string. And we can go ahead and parse these JSON strings for different things like the error code, the error message, anything else, any other parameters that we need to pass back. It's super helpful to exit with a JSON string of some kind. In this case, we're just parsing for error. And if error is not empty, like the key error is not empty, we can go ahead and show this custom dialog with our task name. And then we also use something called FM error message. And what FM error message is a custom function that we created or made at some point over at DB. It's been around for a long time. but we can go ahead and put in our error code right here, and that will pop up with something that we can actually view, that we can kind of see what's wrong with in English rather than just seeing a regular code. And then we don't want the script to continue. In this case, we're going to go ahead and exit script again with that JSON string. So we're using error, we're setting that with the error code that we grabbed from the previous script, and so on and so forth. So let's go ahead and debug. We're going to use our step into button to go ahead and step into this script. If we were to step over it, it would run that script and not necessarily get into the nitty gritty. It would just kind of pass over. But we want to actually see the script at this point. So we're going to step into it. Again, just some of our baseline stuff, a different task name. And here's a great example of a false error, an always false error. So this is a great place to put developer-specific criteria. So in this case, it will always pass over. It'll never actually hit, as I'm showing here. But we can actually use our special button here to step into this to run it since we're a developer. This install menu set is a great example of this. Say you're a developer or something like that, you want to use a specific menu set, like a custom menu set of some kind, anything like that. You can use an always false error message or error condition to hide things that are specific for development. Say you don't want to send emails, you have a global of some kind, you don't want to send emails out. You can use something like this as well to just step in to set certain criteria. So super helpful for stuff like that. And then here, oh, look, we have a convenient error. This is an always true statement. So just for the purposes of this demo, we can go ahead and return an error with our exit script parameters. So this is our result. We have a JSON set element string with an error 202 just as a random. And if we go ahead and move on back through, we can use the data viewer to see what this error is. So I just pulled up the data viewer using the button over here. There's two settings. You have current and you have watch. Watch, you can go ahead and add things. You can even add variables. Say I want to see this variable here. We can automatically evaluate. I've also got the Monkey Bread plugin here. The free license, again, super helpful to have. But yeah, we can do all sorts of different things in this data viewer. In this case, I can see the results. The result here is that JSON string that we made in the previous script. And we're pulling the error out of that result, which is 202. So let's get back to our script debugger. We can go ahead and show that custom dialog. It says there was an error running the subscript. And then this right here is our FM error message, which is field access denied. So I can go ahead and press OK. Now I don't actually want to exit this script. I do want to show you guys some of the later on errors that we're going to show you. So I'm going to use this next step. I'm not going to run that at all. And we're going to jump into the next area. The next area is the import record script step. This is always super great to debug, especially if you're importing from somewhere. There's a lot of things that could go wrong, especially with like a dialog on, for example. If you cancel, then you say a user cancels action and you don't actually want to import records, you can go ahead and handle that here, as well as other errors like maybe the source isn't working or various things. That's probably the number one. The source isn't working if you've not got a dialog on. So we can go ahead and jump into that. And let's run through some of this. We're going to import into food. So make sure that's always correct. And we got food name, food category, food description. Perfect. Now we can import. And then this right here, this checkbox it's different for different people. If you want to track things like, say, your serial numbers, your creation timestamps, modification timestamps, etc., this is always a great thing to keep on. If you're re-importing data and you want to preserve some of that information, like you want to preserve who created it or who modified it especially, super great to leave that off as well. So I'm just going to make the choice. This is an example. We can keep it on. That's totally fine. And then we'll see we have no records skipped, no errors, anything like that. So we should be good to go. There we go. We are grabbing the last error in this case. So right after we import our records, we go ahead and set that last error into a variable. The reason why we do this is there are very rare cases where if you just check the last error, get last error is not equal to 0 directly after, sometimes that will change who the last error is. So it's a very rare occurrence, but out of an abundance of caution, we always do it this way. And then we can see here, if we open the data viewer, our last error is 0, so it never hits here as well. So we're looking pretty good. Again, this custom dialog is almost exactly the same. We have a different start to it. That just helps us find exactly where in the code that helps. It's always a great idea to have these custom dialogs be different. That just makes it easier for debugging down the line. If a customer sends you something like a picture or something like that, we can go ahead and search through that and specifically find which line is causing the problem. So again, highly recommend. Next up, we have a find that we are going to error trap here. Finds are a little bit different. We want to check two different criteria here. We want to check if there is an error, and we also want to check if there's a found count, because the found count itself is an error. Say you're searching for something and there's no records at all, that will throw an error, but it's not necessarily an error that the user needs to be aware of. So there are cases where having a 0 record found set isn't a problem, and there's some cases where it is. So you need to judge that based on the kind of code that you're writing. So if we go down and we always do our go to layouts inside of our find mode statements. The reason for this is if there's some sort of like huge calculation, or you have a huge summary field or something like that, depending on the layout that you're looking on, it can be a huge pain to go to the layout first and then perform the find because you're loading all of these records all at once. So in cases like this where the found set's actually quite small and there's no major summary fields or anything like that, totally fine to do it outside. But the correct way for us is always doing it inside our after we enter find mode. So we're going to go to layout. You can see our layout changed over there. We can set a field to perform a find. In this case, we're going to search for butter in our food groups. We perform the find, and then right after that, we're going to grab the last error. So we grab the last error, again, just to make sure that nothing else gets in the way between us and our last error. So we're going to store that, and then we're going to check the found count, because if the found count is 0, that's a different dialog here. Or sometimes it doesn't matter and you just kind of skip through. So in this case, we have a different dialog, says no records found. This additional one that says there's an error finding your records. So there could be some sort of other error that happened that maybe you were prevented from going into find mode, and that's why there's a problem or something similar to that. So there's a reason why we do these separately. As you can see, we did go ahead and find 24 records for butter. So there are no errors, and that is how you error trap a find. Next up, we're going to talk about indirection just a little bit. Indirection is ideally not something that you want to include when you're developing. It's not a good use, it's not dynamic or robust or anything like that. So we tend to avoid it, but there are systems that you may come in contact with if you're using like an inherited system or something like that. Indirection does happen, and we're going to take a look at like what it is and how we can find it, how we can debug issues that have to do with indirection. So below here is an example of indirection. Indirection in FileMaker refers to the ability to reference an object, or like a table, a layout, value list, a field, a script, or anything like that by its name instead of its internal ID, because names can change, whereas internal IDs don't usually change. So generally speaking, we really do want to reference things by internal IDs when we can. In this case, we're referencing a field by its name as a string rather than as the field itself. So in this case, if I were to go ahead and change this name would not automatically update. So let me kind of show you, if we debug this, it'll actually work. It will set the mod timestamp here. So if we go back to this, and let's take a look at that mod timestamp. Okay, so we can go ahead and add a new one here. This is our mod timestamp. This is what it looks like right now. And then if I go ahead and run it, you can see that that's updated to the current date. No problem at all. I'm going to stop this, or I'm going to open up the script itself, and then I'm going to stop this, and we're going to look at something different. If we were to do this the correct way, and say I were to set the field, and then I were to set the timestamp with the get current host timestamp, and I would just save that. Let's run back to the sample, and we can jump through here. So when I'm rerunning a script, I do like to include just the constant variables up top before I go ahead and jump. So if we go ahead and jump like this, we do actually need to go to the correct layout. So I'm going to grab the correct layout. Let's go ahead to the correct layout there. And then let's set that timestamp. Okay, so I set that timestamp right here. Again, you can see that that changed. And if I go ahead and use this one as well, you'll see it changed again, the exact same result. So both of them work. One of them is more correct than the other. And the reason being, if I stop this again, and we go ahead and open the database manager, that is on my keyboard, a Command Shift E, or you can go up here to File, Manage, Database. And I changed this mod tstamp to say mod tstamp demo. And I change it like that. And I press OK. If I go back to our script here, let's go and make sure we go to the correct layout. Again, it says field missing. So not ideal, but again, this one here has been updated. It does say mod tstamp demo. So this is a great example of indirection. Using indirection is not ideal. You should not be doing it. If you do want to read up more about indirection and examples of indirection, how to avoid it, you can go ahead and check out our article. It's called Building a Dynamic and Robust FileMaker System, and it's linked in the article as well. So go ahead and check that out if you want more examples of indirection. All right, so before we go to open records requests down here, let's take a break for a moment and talk about DDRs, what they are, how to use them, etc. So DDRs are extremely useful for finding examples of indirection. So in this instance, we would be looking for mod tstamp or anything else that has mod tstamp and other examples of indirection. We can actually pull a database design report from up here. See, we click this, we'll have something that pops up. If you have a inherited system or something like that that has multiple files, which is pretty common, you can go ahead and select as many or as little as you'd like to include in this DDR, and it will actually show you the relations between each of the files if they are related. So in this case, we're just doing one for this testing your work template. We're going to always do XML. And then I uncheck this. I don't really need it to automatically open for me. And then we press create. And it's going to ask you to save it somewhere. So I'm going to go ahead and save it just to my demo test folder. What I usually do is put in the date. I think today's the 28th. Perfect. And then sometimes I'll put in the company name. Sometimes I'll put it in the customer file and whatnot. In this case, it's just a demo, so we'll pop it in here. And then we like to use our handy dandy tool called Base Elements. This is Base Elements 20. I think the newest version is 21 out here. I'm still using 20 just for an example. But what you can do with Base Elements, what it is it actually parses that XML file for you. So it goes based off of the summary XML file. It's super, super cool. You can just import it, super easy. Summary XML, perfect. And then you open it, and then you can go ahead and put in some sort of customer name or client name, anything like that. You don't have to do that. You just press continue, and then depending on how big your file is, this may take a while, this may be really quick. In this case, we have a super small file. So this is very, very quick. And what this does is it has the list of files. You can go through even each file individually, or you can go through a specific one. And you can go by table, by layouts, by scripts, and then even more granular by like fields, relationships, even objects, script steps, things like that. And this is super, super cool for finding all sorts of things. Like if you're looking for an email, for example, you want to know where this email is coming from, you can even go to like script steps, and you can put in maybe a send mail script step. We don't have any in this case, but you could find all of the script steps that say send mail. You could find bodies of emails if you have them in like some sort of variable before you send them. In this case, we can find all of our variables, all sorts of things. And this could be what helps with our indirection problem. So say I want to find, what was our field for indirection? Let's say, oh, mod T stamp. Okay, so let me just say mod T stamp in here and see what comes up. Oh, okay, I've got two different instances where we use mod T stamp. One's mod T stamp demo, one's mod T stamp. Oh, this is the one I'm looking for. I can go ahead and take a look at where it is, at what script it's in. If it was calculation, I could see like the items used, like here. And there's a lot that you can do with this. So again, a super, super helpful tool that we like to use over here at DB Base Elements. Go ahead and check it out. You can download it off of their website, and we use this just all the time at DB. It's very, very helpful. Jumping back into our file over here, we can go ahead and talk about some more error trapping examples. Okay, next up is open record request. Open record request is something that we use occasionally. It really depends on what you're doing, whether or not you should use it. But what we use it for is generally checking to see if somebody else is modifying the record that you want to modify. So you could say, like in a list, if you have a list of records that you're trying to update and you want to make sure that all of them are updated, you can go ahead and check this open record request before that, or you could check and make sure that it is open before you modify a bunch of different records in here. And that could save you a lot of headache if you go through and modify a bunch of fields afterwards. You can also do this by modifying the T-stamp, kind of like what we were doing up here. And if you get an error by using this last error script step here, you can see if the record is modifiable or not. So again, it depends kind of on the circumstance of whether or not you use this, but how we use this, and let me go back over here, get into our found set like we were before. We can actually, this is a great opportunity to set a breakpoint. So I've just set a breakpoint by pressing on the numbers over here on the left side. I can go ahead and press the play button, and it takes me directly to that line in particular. Press it again, removes it. Super easy. Now I'm going to step on through here. As you can see, there's nobody else in the system, so I'm not expecting an error here or anything like that. But we can go ahead and move on to our next error trapping example, which is go to related record. Here at DB, we don't use a ton of these. They are kind of like a once in a blue moon occurrence, but they do happen occasionally. I prefer not to use them unless I have to, but in the case that you do have to use a go to related record, here is how you would error trap it. So in this case, I'm going to grab the food ID, which is just the primary key for food. Whatever food item it is, butter, I guess. And then we're going to go to menu. And in menu, I'm going to set a global called ZGT food ID with my chosen food ID variable. And then I am going to grab the layout that I'm currently on, and I'm going to store that in a variable. So in this case, we can even go ahead and take a look at that. My starting layout name is called menu. And now I'm going to use that go to related record script step using a different layout. So in this case, I'm going to be using food list view. And when I go to that different layout, if the go to related record was not successful, I would still be on the same layout. So that's what we're going to check for. We're going to make sure that our layouts change. So here we know that they changed, but then we're going to grab this new layout name and we're going to compare it against our variable with the starting layout name. And if that hits, well, obviously it didn't because we successfully used a go to related record. But if it did, then we would go ahead and catch that error there. Next up is PSOS Subscript. So this one's interesting because there's two different ways you can error trap for this. And it depends on kind of whether or not you have the wait for completion on or off. So if you have wait for completion off, that means that the subscript will just run on the server and we aren't waiting for any kind of response. So we can't really error trap that. You can use PSOS with callback. Actually, I have an article on that one that I wrote not too long ago. You can go ahead and check that one out. We can go ahead and link that one as well. So that one you can error trap while not waiting for completion. But for the regular PSOS, you have to turn on wait for completion if you want to check your result for an error to make sure it worked successfully. You also need to make sure that there were no errors when you go to run the perform script on server. So if I run this right now, because this is not a hosted file, I'm just running this off of my MacBook Pro here, I'll go ahead and get an error. So that's because it's not hosted. If I had this hosted, definitely would be working, but this is a great example of what happens and how this error trap works. So it goes ahead and checks that last error there, which is last error 3. It goes ahead and shows that custom dialog. There was an error regarding the PSOS, which is what we had written here. But then this is also our FM error message, again, at work, which we love FM error message. It is so helpful sometimes. And then after that, we can go ahead and check our result right here to see if it's got another error, similar to how we did before up at our perform example subscript, perform script step right there. So it's exactly the same how we would go ahead and check. Okay, next up we have export records in the script step. So this is pretty straightforward, but we do always want to error trap whenever we export records as well as import them. It's probably more important to check if they were imported correctly rather than exported. But if you're doing something like automatically sending an email with some sort of exported records, or you're maybe checking if the found set is correct or anything like that, we do want to error trap whether or not the exported records have been exported correctly as well. So here's another example. So we can go ahead and grab the file path and then export the records. It will disappear while it pulls up. The script debugger will disappear while it pulls up your export. But as we can see, it all looks pretty good. And then I just click on the app to make the script debugger reappear again. No problem. Here's an example of why you should always step into your error traps. So even though I know that it passed and whatnot, as a developer, I should manually step in here using the set next step command button up here. And the reason why is you always want to make sure that there's no spelling errors or anything else like that when you're testing your work. So obviously there are plenty of spelling errors in here. There's also no space, which is a common thing to do. If you're adding additional custom functions or anything like that, you want to make sure that there's a space right in there so that there's no other issues or anything like that. It's always really important to test your error trapping as well. So we can go ahead and say, okay there, I'm going to step out of this. And that concludes all of our different ways to error trap. Again, this is just a subset of examples. There's a lot of different things that you should error trap. If there's something that could go wrong, if you're trying to get to a layout and then you're not really sure if you are there or something like that, you should always error trap anything that you're not sure about. And that'll always help for a add to your robust systems and how to make that. So as you can see, good testing isn't just about making sure things work when everything goes right, but it's more about preparing for when things go wrong. So by building error trapping into your scripts and thinking like a user and taking time to manually test critical workflows, you make your FileMaker solutions more stable, more professional, and way easier to maintain without that indirection and everything in the long run. So thanks for following along with me today. I hope this gives you a better idea of how you can use FileMaker's tools and best practices to deliver better, more reliable applications. Happy developing!